So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation, that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, welcome to this problem solving video. So let us read out the question. So in this question it is saying that carrier signal is given as C of t 5 cos 2 pi into 10 to the power 6t. Message signal is given as cos 4 pi into 10 to the power 3t. Now this both CT and MT are used to generate FM signal and whose maximum frequency deviation is 3 times the bandwidth of amplitude modulated signal. And we have to find out the coefficient of this cos 2 pi 1016 10 to the power 3t in FM modulated expression. So let us start with the given data. So the carrier which is given as 5 cos 2 pi into 10 to the power 60, and your message signal is cos 4 pi into 10 to the power 3t. So you can compare your message signal. It is a single tone sinusoidal. So upon comparison, you can write it as cos 2 pi FMT AM. So this AM from here comes out to be 1 and 2 pi FM comes out to be 4 pi into 10 to the power 3, or this FM can be written as 2 kilohertz. So this is the information given. This AM is 1 volt and this FM is 2 kilohertz. So in the question, it is talking about two signals. One is amplitude modulated signal, another one is frequency modulated signal. So we know that if we calculate the bandwidth of AM signal, so bandwidth of AM signal for single tone sinusoidal signal becomes 2 times F max, or it becomes 2 FM, or you can call it as 4 kilohertz. Now it is also given that the maximum frequency deviation, which is nothing but mod of delta Ft max, is equal to 3 times the bandwidth of FM. So this will be the bandwidth of FM. So you can write this expression as delta Ft mod max equal to 3 times bandwidth of AM. So bandwidth of AM will become 2F max. So this mod of delta Ft max upon F max becomes equal to 6, and you know that this ratio defines your beta FM. So from here you can calculate that beta FM is equal to 6 and it is very much greater than 1. So obviously it is the case of wideband FM. So we can write the general expression of wideband FM. General expression of wideband FM becomes summation of AC chain beta cos 2 pi FC plus n FM into t, and n varies from minus infinite to plus infinite. So in this case we already know about the FM, we do not know about this AC and FC. So let us once again recall the carrier signal. The carrier signal was given as 5 cos 2 pi into 10 to the power 60. So upon comparison with AC cos 2 pi FCT, you can obtain AC to be 5 volt and FC can become 1 megahertz. This 1 megahertz can also be written as 1000 kilohertz. So this S of t becomes summation of n equal to minus infinite to infinite 5 jn. Beta we have already calculated as 6 cos 2 pi. FC comes out to be 1000 kilohertz and FM comes out to be 2 kilohertz. So this 10 to the power 3 I'm writing outside, and becomes like this. Now we have to find out the coefficient of cos 1016 into 10 to the power 3t. So if we have to write this particular expression, which is equal to cos 1016 into 10 to the power 3, so it would happen on a specific value of n. So let us calculate. If this 2 pi into 1000 plus 2n into 10 to the power 3 becomes equal to 2 pi into 1016 into 10 to the power 3, so it will become 1000 plus 2n equal to 1060, or 2n becomes equal to 16, or n you can calculate it as 8. So if I will put the value of n as 8, then out of this infinite number of terms only one term will remain. So if I will put n equal to 8 here, So it becomes 5 J86 cos 2 pi into 1016 into 10 to the power 3t. So from here you can say that the coefficient of cos 2 pi into 1016 into 10 to the power 3t comes out to be 5 J86. So this should be your answer for this particular question. So in this question it was asking about the coefficient of this particular expression in FM expression. So FM expression will be for WBFM expression because this beta which you calculated was greater than 1. So in that case we used the expression of WBFM and we calculated the value of n which was 8. So whenever you put the value of n as 8, so you can find out this expression. Now let's move on to the next question. So in this case, a frequency modulated signal is given as 100 cos 2 pi fct 4 sin 6000 pi t. So an FM signal is given as 100 cos 2 pi fct plus 4 sin 6000 pi t, where fc is given as 1 megahertz. So first of all we have to calculate the modulation index, then we have to calculate the coefficient of the term which is cos 2018 pi into 10 to the power 3t in terms of Bessel's function, and finally we have to calculate the ratio of this coefficient. Now first of all let us understand what is the modulated signal. So the modulated signal is 100 cos 2 pi fct plus 4 sin 6000 pi t. So I can compare this expression with AC cos 2 pi fct plus beta sin 2 pi fmt. So upon comparison you can get AC as 100, FC is already mentioned in the question, it is 1 megahertz, and value of beta comes out to be 4 which is greater than 1. So obviously it is the case of wideband FM. This 2 pi FM becomes 6000 pi, or FM can be written from here as 3 kilohertz. So the modulation index which it was asking about is coming out to be 4, and this beta equal to 4 represents that it is the case of wideband FM. Now in the second part we have to calculate the coefficient of this term in terms of Bessel's function. So we know that if we get beta equal to 4, or which itself becomes the case of WBFM, so the same signal expression which is given as S of t equal to AC cos omega ct plus beta sin 2 pi fmt, this expression can be alternatively written as S of t equal to summation of AC jn beta cos 2 pi fc plus n fm into t, and where n varies from minus infinite to plus infinite. So this S of t can be written as n equal to minus infinite to infinite. This AC becomes 100 jn beta you have already calculated as 4, and it will become cos 2 pi. FC is given as 1 megahertz, so you can write it as 1000 kilohertz. FM again you have calculated as 2 kilohertz, so it becomes FM you have calculated as 3 kilohertz, I guess. Yes, FM is 3 kilohertz. So you can write it as 3n into 10 to the power 3t. So from here you can see that you have to find out the coefficient of the term which is cos 2 pi into 1009 into 10 to the power 3t, because you have to find out the coefficient of 108 pi. So 2018 pi becomes 2 pi into 1009. So its coefficient needed to be find out. So what we will do, first of all we will compare this expression with this. So we get 2 pi into 1000 plus 3n into 10 to the power 3 equal to 2 pi into 1009 into 10 to the power 3. So upon this comparison you get 1000 plus 3n equal to 1009. 3n becomes 9, or value of n comes out to be 3. So if you will put value of n equal to 3, then out of this infinite number of expressions only single expression will remain, and it will become 100 J34 cos 2 pi into 1009 into 10 to the power 3t, or you can write it as 100 J34 into cos 2018 pi into 10 to the power 3t, or the coefficient can be written as 100 J34. So this will be your coefficient, and this should be the answer for the B part. Now let's come on to the C part. In the C part, it is asking us to calculate the ratio of the coefficients of terms cos 1976 pi into 10 to the power 3t and cos 2024 pi into 10 to the power 3t. So we have to calculate their coefficients. So first time I'm taking it as your general expression of WBFM. So it becomes minus infinite to infinite AC j and beta cos 2 pi FC plus NFM into T. So this can be written as n equal to minus infinite to infinite. AC is 100, beta you have already calculated as 4. It will become cos 2 pi. FC is 1000 kilohertz. This is 2 kilohertz. So it becomes 2 n into 10 to the power 3t. This is your ST. Now, if you have to find out the coefficient of 1976 pi into 10 to the power 3t, so in that case, you should equate this 1976 pi into 10 to the power 3 with 2 pi into 1000 plus 2n into 10 to the power 3. So this 1000 plus 2n becomes equal to 1976 pi upon 2 pi. So this can be written as 2n equal to minus sorry, it should be 3n here. This is 3n. So this 3n becomes equal to minus 12 and n comes out to be minus 4. So if you will put n equal to minus 4 in this expression, so it becomes 100 j minus 44 into cos 1976 pi into 10 to the power 3t. So the coefficient of this term, which is 1976 pi into 10 to the power 3, comes out to be 100 j minus 4 of 4. Now let us find out the coefficient of the term, which is cos 2024 pi into 10 to the power 3t. So from this again you have to write the general expression, which is summation of AC cos 2 pi FC plus n fm into t, where n varies from minus infinite to plus infinite. Or you can write it as n equal to minus infinite to infinite 100 cos 2 pi into 1000 plus 3n into 10 to the power 3t. So again, you have to compare this expression, which is 2 pi into 1000 plus 3n into 10 to the power 3 with 2024 pi into 10 to the power 3. So from the calculation you can get 1000 plus 3n equal to 1012, and from here you can calculate the value of n again as 4. So if I'll put value of, there will be AC j n beta. So this will be 100 j n beta. So if you will put n equal to 4 here, it becomes 100 j4, and the value of beta you have already calculated as 4. So if you will calculate the ratio of 100 j minus 4 of 4 upon 100 j4 of 4, we know that j minus 4 will become 100 into minus 1 to the power 4 j4 of 4 upon 100 j4 of 4. So overall this ratio becomes 1, and you can obtain the ratio. So the C part answer was 1. Now let's move on to the next question. So first of all, let us read this question. In this question it is saying that a sinusoidal carrier of frequency Fc is used to generate both AM and FM. Now transmitter is used to transmit both AM and FM signal with message signal frequency of 5 kHz, and maximum frequency deviation of FM is twice the bandwidth of AM. Now we have to find the modulation index for both AM and FM such that the strength of the frequency component, which is Fc plus 5 kHz, is same in both AM and FM spectrum. So first of all, let us try to break down the information what is given. First of all, it is saying that we have a carrier frequency Fc which is helping us to generate both AM as well as FM. Now the second information which is mentioned is that the message signal frequency, or the message which has been transmitted, it has the frequency which is equal to 5 kHz. Third information is given regarding FM. So regarding FM, it is saying that the maximum frequency deviation of this FM is equal to 2 times the bandwidth of AM. So this mod of delta Ft max becomes equal to 2 times bandwidth of AM. What will be the bandwidth of AM? It will again be 2 times the maximum frequency component in the message signal, which is this. Now from here you can calculate the ratio of mod of delta Ft max upon F max. It comes out to be 4, and very clearly it is nothing but your beta FM, and also it is the case of WBFM because beta is greater than 1. So initially it was asking about the modulation index of both AM and FM. So the modulation index of FM becomes modulation index of FM becomes equal to beta FM, and it becomes 4. So this becomes your modulation index of FM. Now another information is given that the strength of the frequency component Fc plus 5 kHz is same in both AM as well as FM. So we know that in case of AM, if I talk about in case of AM spectrum more clearly, in terms of AM spectrum, so we know that the frequencies and their strengths. So the strength of Fc in spectrum becomes AC by 2, and strength of Fc plus minus FM becomes mu AC by 4 in the spectrum. So this is the strength. Now in this case you can see that since your Fc is mentioned as Fc and FM is mentioned as 5 kHz, so in case of AM spectrum, this spectrum is having strength of mu AC by 4 for this Fc plus minus 5K. So First of all, in case of AM spectrum, the strength of this Fc plus 5k becomes equal to mu AC by 4. We also know that in case of FM spectrum, the strength of Fc remains AC by 2. The strength of Fc plus Fm becomes AC J1 beta by 2, and this Fc plus Fm is nothing but Fc plus 5k. So in case of FM spectrum, we had also made the table that the strength of this Fc plus 5k will become AC J1 beta by 2. So according to the given problem, the strength of the frequency component in AM, which is Fc plus 5k in FM, and the strength of the Fc plus 5k in FM has to be same. So it will become mu AC by 4 equal to AC by 2 J1 beta. Beta you have already calculated. So from here AC gets cancelled out. This will become 2 times of J1 beta. Beta you have already calculated, which was equal to 4. So from here it becomes 2 times of J1 4. Now let us see what is the value of this J1 4 is given. Now in the problem, the value of all these informations are with respect to J1. This is J1, this is also J1, this is also J1. So this is the table of the J1. So you can see this J1 4 is given as 0.37. So this mu can be written as 2 into 0.37, or the value of mu can be written as 0.74. So this was also very simple question. It was connecting both AM and FM. And the data which was given here was data of the J1. There is no need of J2 data in this question. So it was just misprint. So you must take care that you must take the data of J1 from here. Now let's proceed on to the next question. So let us try to read this question, what it is saying. It is saying that a sinusoidal carrier is frequency modulated by sinusoidal message signal of frequency FM and amplitude AM. So in this case, carrier is also sinusoidal and message signal is also sinusoidal. And the frequency of the message signal is FM and amplitude is given as AM. So if I consider my carrier, so I can consider a general carrier to be AC cos 2 pi FCT. And if I have to consider a message signal, so I can consider it as AM cos 2 pi FMT. So the value of this AM is given as AM and frequency is mentioned as FM. Now let us read the question after this. So after this it is saying, while conducting an experiment with FM equal to 1 kilohertz. So it is conducting an experiment in which FM is chosen to be 1 kilohertz and it is increasing your message signal amplitude from 0 volt. So while it was doing so, it is observed that the strength of the carrier frequency becomes 0 for the first time when AM becomes your 2 volt. So initially in the first experiment, what it is doing, in this experiment, what it is doing, it is increasing AM from 0 volt, and while it increased it from 0 to 2 volt, the carrier frequency component becomes 0 for the first time. So the carrier frequency component will be 0 for the first time. What it is suggesting us that we know that in case of frequency modulation, the carrier frequency component is AC J0 beta by 2. So as soon as this AM increases from 0 volt to 2 volt and FM is kept constant, which is 1 kilohertz, so it is kept constant. So as it increased from 0 to 2 volt, this carrier frequency component at this AM equal to 2 volt becomes 0 for the first time. So this becomes 0 for the first time. we know that J naught beta can become 0 for different values of beta, which is 2.4, 5.5, 8.6, 11.8. So for the first time, since it is becoming 0, so you must consider that beta would have been 2.4. So for the first time 0, this beta can be considered as 2.4 or 0. So from the first expression, we concluded that the value of the beta can be considered as 2.4. So this becomes your beta. Now, after that, it is saying that we have to calculate KF. So let us try to calculate the KF. So when FM was 1 kilohertz, AM increasing from 0 to at it increases 2 volt, the beta becomes 2.4. So we know that for sinusoidal signals, beta is nothing but KF AM upon FM, and obviously KF must be in hertz per volt. So whenever KF is in hertz per volt, we can use this formula. So from here, the beta becomes 2.4, KF is unknown, this is 2, and FM is your 1 kilohertz. So from here, the KF comes out to be 1.2 kilohertz per volt. This is the answer for the first part. Now let us see what it is asking in the second part. In the second part, it is asking find the message signal's amplitude for which the strength of the carrier frequency components becomes 0 for the second time. So we know that whenever the carrier frequency component will become 0 for the second time, so obviously for the first time, if we chose the beta to be 2.4, for the second time this beta has to be 5.5. So in the second case, or in the second part, it is given that AM has to be changed, message signal frequency it is keeping as it is, KF is a constant, so I can write it as 1.2 kilohertz per volt, and beta will now become 5.5. So for sinusoidal signal, again you can write beta equal to KF AM upon FM. So the value of AM becomes beta FM upon KF. The beta becomes 5.5, FM becomes 1 kilohertz, and it becomes 1.2 kilohertz per volt. So upon solving all these values, you can get AM equal to 4.58 volts. Now let's move on to the next question. So let us first of all read this question. In this question, an unmodulated FM transmitter power is given as 100 watt, and with the modulation, it is observed that the strength of the first order sidebands are 0. So first of all, let us try to extract the informations which are given in the question. So in this question, it is saying that initially unmodulated FM transmitter power was given as 100 watt. So we know that unmodulated means unmodulated FM means message signal has not been arrived or only carrier is present. So we can write the carrier power, which is AC square by 2, we can consider it is given as 100 watt. So if I consider my carrier to be AC cos 2 pi FCT, so I can write this power of the carrier as 100 watt. Now another information is given as with modulation it is observed that strength of the first order sidebands are 0. So we know that the strength of first order sidebands depends upon J1 beta. So if J1 beta will become 0, so the strength of the first order sidebands will also become 0. So finally we have to make this J1 beta 0. Now you can see that from the given table, at what value of beta this J1 beta becomes 0. So this is the table for J0, this is the table for J1, this is the table for J2. So we have to strictly look in the table of J1. So if you will look closely, you can see that this J1 beta becomes 0 for beta equal to 3.8. So from here we concluded that the value of beta must be 3.8. So in the first option it is asking us to calculate the power of the carrier frequency component. So we know that the power of the wideband FM is nothing but PC into J0 square beta plus 2 times J1 square beta, J2 square beta, J3 square beta up to infinite. So if I have to calculate the power of carrier component in wideband FM expression, so it becomes PC into J0 square beta. And if I allow all these spectrums to add up to infinite, then it will become equal to PC. So this we already know. So now the power of the carrier component becomes PC J0 square beta. So you can write it as PC J0 square 3.8 because beta you have already calculated and it was coming out to be 3.8. So this J0 3.8 becomes 0.4. You can put this value here. Value of PC is given as 100. It is your 0.4 square, or it becomes finally your 16 watt. Now in the second part, it is asking about the total sideband power. So we know that total WBFM power is equal to FC. So total sideband power can be written as power of WBFM minus power of carrier component. So complete power of WBFM you can write it as PC because in case of WBFM the power before modulation and after modulation remains same. So if I allow the infinity number of sidebands, then this total power will become PC. So you can write this as PC minus PC J0 square beta. So PC becomes 100, this becomes 16, and this answer comes out to be 84 watt. Now in the third part it is asking about the total sideband power of the second order. So since J1 beta is 0, so this will also become 0, and if it is asking about the total sideband power of the second order, so it will become PC into 2 times of J2 square beta. So for the third part, the total sideband power for second order sideband, so it becomes PC into 2 into J2 square beta. So total second order sideband power will become 100 into 2 into J2 square 3.8. So you can calculate this. J2 3.8 is mentioned as 0.2. So let me put this value here. It will become 200 into 0.2 square, or you can write it as 200 into 2 into 10 to the power minus 2, or it will become 4 watt. So all these three questions you can calculate, and it was based upon the power calculation in the WBFM. So let's move on to this next question. In this question it is saying that we have a modulating signal which is 3 cos 10 pi t. So from here you can say that this modulus of mod of empty max will become 3, and the maximum frequency component which is present in it is 5 Hz. So this is information from m of t. Now another signal, which is your frequency modulated signal, will become 20 cos 4000 pi t plus 2 pi kf minus infinite to t mt dt. And kf is given as 10 Hz per volt. So from here you can see that this is your theta it. So I can write this as theta it equal to 4000 pi t plus 2 pi kf minus infinite to t mt dt. So you can differentiate on both the sides. It becomes omega I as a function of t equal to 4000 pi plus 2 pi kf mt. Now from here you can write fit equal to 2000 plus kf mt. So from here this delta ft can be written as kf mt, and mod of delta ft max can be written as kf mod of mt max. Kf is 10, mod of mt max is given as 3. So it comes out to be 30 Hz. Now if I have to calculate the beta from here, so beta will become mod of delta ft max upon f max. So it becomes mod of delta ft max by 30, f max is 5, which is 6, and it comes out to be the case of WBFM. So from the initial information we extracted that this particular expression of the FM, which is given as 20 cos 4000 pi t plus 2 pi kf minus infinite to t mt dt. This particular expression of FM is the expression of wideband FM. So this is the expression of wideband FM. Now we know that in case of wideband FM, the frequencies contained by the FM signal is FC, FC plus minus FM, FC plus minus 2 FM, FC plus minus 3 FM, and so on. So these are the frequencies contained by the frequency modulated signal. So if you will compare this expression with AC cos 2 pi fct plus 2 pi kf minus infinity to t mt dt. So upon comparison you get AC as 20 and FC as 2 kilohertz. FM you have already calculated as 5 Hz. So you can calculate the frequency component present in FM is FC, which is 2 kilohertz, FC plus minus FM, so it becomes 2000 Hertz. It becomes 2000 plus minus 5. FC plus minus 2 FM will become 2000 plus minus 10. FC plus minus 3 FM will become 2000 plus minus 15. So this is your carrier component in FM modulated signal. This is first order sideband. This is your second order sidebands. This is third order sidebands. Similarly, you can calculate your fourth order sideband, FC plus minus 4 FM. So this will become 2000 plus minus 20 and so on. Now what it is doing, it is passing this FM signal with an ideal bandpass filter, and we have to calculate the power of the output signal. And the bandpass filter which is mentioned here is centered at 2000 Hz. It is centered at 2000 Hz and it has the bandwidth of 31 Hz. So if it is having the bandwidth of 31 Hz, so it will become 201.5 and it becomes 1984.5. Similarly on the negative side also, minus 2000 minus 1984.5 minus 201.5.5. This becomes 1. So you can say that this particular bandpass filter will allow frequencies from 1984.5 to 201.5.5. So the carrier frequency component in the modulated signal has frequency FC, which is 2000 Hz. So it will be allowed by the filter. Now the first order sidebands, which is 2000 plus minus 5 or 2005 1995. This is your first order sidebands. So this will also be allowed by the filter. Let us see about the second order. So second order sideband becomes FC plus minus 2 FM or 2000 plus minus 10. So it becomes 2010 1990. So it will also be allowed by the filter. Let's come on to the third order. In case of third order, it becomes FC plus minus 3 FM or it becomes 2000 plus minus 15. So it becomes 2015 1985. It is also allowed by the filter. Let's come on to the fourth order sideband. So this fourth order sideband will become FC plus minus 4M. And this value becomes 2000 plus minus 20. So it becomes 1980 2020. So it will not be allowed by the bandpass filter. So bandpass filters allows the carrier frequency component, the frequency components of first order sideband, second order sideband and up to third order sidebands. So we know that total power of WBFM becomes PC J0 square beta plus 2 times J1 square beta, J2 square beta, and we have to consider the sidebands power only up to third order sidebands. So it becomes J0 square beta plus 2 J1 square beta plus 2 J2 square beta plus 2 J3 square beta. So this will be your power of the output signal YT, because at YT only these frequency components will be allowed. So this is it in this lecture, in this problem solving lecture. So in the next class we will try to solve the questions of the next topic.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is Vishal Gate. Write my name and attach GATE to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code Vishalgate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription, cost of the plus, it is your 27,000 after discount. if you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay. You can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.